Hello guys, my name is IBM and I bring you Physics 9702 paper 1. This is component 1, 2. This is this is October, November 2022. So I'll take you to the question paper. So the paper is supposed to be 1 hour and 15 minutes. I may take more time, I may take less time depending on how I explain the concepts. So I'll take you to the questions straight away. I will not read through the instructions. You can always read through the instructions. I will go straight to question number 1. Which quantity is a physical quantity? Of course, a physical quantity should have a unit and a magnitude. So a flavor, that is a quark, a type of a flavor, that is in another word to mean a type. Then Kelvin is just a unit, not a magnitude. Minute is just a unit. Potential difference has a unit and a magnitude, so the answer is going to be D. Physical quantity can be measured. Because it can be measured, it has a unit and a magnitude, so the answer is going to be D. It is a physical quantity because it can be measured. And if it can be measured, it has a unit and a numerical magnitude. So what is the power of 3.7 megawatts when expressed in kilowatts? So I'll first change 3.7 from mega to watts, so that is times 10 to the power of 6. That is now in watts. To change it to kilo, I will divide by 1000, so it will be 3.7 times 10 to the power of 6 divided by 1000 to change it to kilo. So 3.7 exponent 6 divided by 1000. So that's 3700, which is 3.7 times 10 to the power of 3. Oh, sorry. This is 3.7 times 10 to the power of 3. So this is in kilowatts. Because when I divide by 1000, I change from watt to kilo. So the answer here is going to be C. A spring is suspended from a fixed point and a force is applied. The position of a pointer attached to the bottom of the spring against a vertical ruler is recorded. Before the force is applied, the position of the pointer is 225 plus or minus 2. After the force is applied, the position of the pointer is 250 plus or minus 2. So the extension of the spring is determined. So it means the extension of the spring is going to be the difference, which is going to be 250 minus 225, which is going to be 25 millimeters. That is the extension. And what is the percentage uncertainty? So this is the extension. Let me use, okay, that is the extension. Then the uncertainty, so absolute uncertainty in the extension, I'll use E. Okay, let me use E for extension. Absolute uncertainty in extension. Of course, the uncertainty simply accumulates, doesn't it? We can't subtract the uncertainty, so it will be 2 plus 2, which becomes 4 millimeters. So percentage uncertainty is going to be 4 divided by 25. I multiply this by 100. So this is 4 divided by 25 times 100, which is 16%. So this is 16%, so the answer is D. What is the difference between a scalar quantity and a vector quantity? Of course, a vector has direction plus magnitude. A scalar has only magnitude. So a vector has direction, but a scalar does not. So I think the answer is automatically C without checking the rest. A vector quantity has direction, but a scalar quantity does not, which is true. Of course, they both have magnitude. A scalar does not have direction. A toy car travels on a circular track at a constant speed of 0.5 meters per second. So the speed is constant speed. So remember, if it is a circular track, and let's say it is at this point, the velocity is in that direction. Remember, the speed is the magnitude part of the velocity. So if the speed is constant, it means the magnitude part does not change, but the direction keeps changing, which means the velocity changes. It passes a point on the track at a time t equals to 0. So let's say at t equals to 0, it is here. And it takes a time of 40 seconds to travel once. So it moves after 40 seconds, t equals to 40, it is back at the same point, which means after t equals to 40 seconds, the displacement is 0. If the displacement is 0, it means the velocity is also going to be 0 after 40 seconds. So after 40 seconds, it comes back to the same position where it started from. So if the displacement is 0, it means the velocity after 40 seconds is going to be 0. So V40, the magnitude of the average velocity of the car between t equals to 0 and t equals to 20 seconds is V20. The magnitude of the average velocity of the car between t equals to 0 and t equals 40 seconds is V40. So V40 is going to be equal to 0. So we ignore D and B. V40 is equal to 0 because displacement equals to 0. The change in this, it moves from it has after 40 seconds has returned to the same point. So the displacement goes back to 0. Okay. So what are V20 and V40? Now, of course, without even calculation, I will know that C is going to be wrong. Why is C going to be wrong? Because when the direction changes, at 20 seconds, we are somewhere away from where we started from. That means the displacement, let's say assume at 20 seconds we are at this point P here. So at 20 seconds we're at that point, the displacement is going to be this distance here, which is this, considering that and that will be the displacement there, which could be found from Pythagoras theorem. So at 20, if the speed is 0.5 seconds, because the direction changes, so it means the displacement cannot be the same as the speed when the direction has changed. So I mean the velocity cannot be the same as the speed when the direction has changed in magnitude. So this one cannot be correct because velocity not same as speed when direction changes. If at t equals 0, we started from this point, and t equals to 20 seconds, we are at this point, there has been a change in direction. So the velocity cannot be the same as, the average velocity cannot be the same as the speed when there has been a change in direction. So that means the C is also out. So the answer is going to be A. Velocity at 40 seconds is 0. Velocity at 20 seconds is a value which is different from 0.5 because there has been a change in direction. The graph shows how the velocity v of an object moving in a straight line varies with the time t from t equals to 0 to t equals to capital T. So it is velocity, which graph could represent the displacement s of the object from time from t equals 0 to t equals to capital T. Remember, um, the gradient of a displacement time graph is the velocity. So gradient here is going to be the velocity. But they say we are seeing that the velocity at t equals 0 velocity is equal to 0. That means the line should be horizontal. Remember, the gradient of a displacement time graph is the velocity. So it means the C is out because at t equals 0, the line is not almost horizontal. And B is also out because at t equals to 0, the line is not horizontal. So from the graph, it shows 0 velocity here. So this is 0 gradient should be equal to 0 from displacement time graph. So we have to choose between A and D. Then At t equals to half a cycle, half of t, again velocity goes to 0. That means again here the gradient should be 0. So we can check at t equals to half of t, the gradient, the gradient should be 0. So here we see it is 0 here, the gradient is 0 there. We also see that the gradient is 0 here because it is a tangent. Okay, so that is not enough to distinguish the two. Then at t equals to capital T, it is again 0. It is 0 here, it is also 0 here. Okay, we cannot use that. Then let's look at what is happening between t equals to 0 to t equals to half of t. Here the velocity increases, which means the gradient should increase, and then the velocity becomes maximum. So the gradient should increase to maximum, and then the gradient should decrease to 0. So here this part is showing that the gradient is increasing. Here gradient is 0, so v is 0 here. Here the gradient is increasing, so v is increasing. Then somewhere here gradient decreases, so v is decreasing because the line is becoming horizontal. Here gradient is 0, so here v is equal to 0. That is at in between the two, so at half t is equal to 0. Then here you see that the curve is going downwards. The gradient is increasing but in the opposite direction. And here the gradient is decreasing, and here the gradient is 0. So velocity here is 0. So it means our graph is going to be A, because D is not depicting what is happening here. Velocity increases to maximum at a quarter a cycle, at a quarter of t, then it goes to 0 at half t, which is being shown by the first graph. The velocity increases to maximum, then it decreases to 0. So somewhere in between here, the velocity goes to maximum. Remember, the gradient of a velocity time graph is the gradient of a displacement time graph is the velocity. So it means the graph A is representing, when I find the gradients of the graph A, I get that second graph. So the answer is going to be A. A goods train passes through a station at a steady speed of 10 meters per second at time t equals 0. An express train is at rest at the station. The express train leaves the station with a uniform acceleration of 0.5 meters per second just as the goods train goes past. Both trains move in the same direction on straight parallel tracks. At which time does the express train overtake the goods train? So when they overtake, it means they have traveled the same distance right from where the express train started from. So here it means they have moved the same distance at the point of overtaking, just overtaking. They would have traveled the same distance as the express train, or the same distance from the point where the express train started from. So the distance is going to be the same. Same distance has been covered at that point when they overtake each other. So I will start with the goods train. So S equals to UT plus a half. Because it was moving at a constant speed, so for it, S is going to be 10 times the time it takes. I will call T. Then that is for the goods train. Then for the other one, which was moving at a uniform acceleration, I will use the equation of motion. S equals to UT plus a half AT squared. If it starts from 0, then S is equal to a half times this acceleration, which is 0.5, then times T squared. We say they travel the same distance, so I will just equate the two equations. So I will say 10 t is equal to a half times 0.5 t squared. So I think t is going to be 20 t 20 divided by 0.5, which is 40 seconds. So they are going to catch up. At which time t does the express train overtake the goods train? So it is good. They are going to catch up after 40 seconds. So that means at 40 seconds. A constant resultant force F acts on an object of mass m for a time t. What is the change in momentum of the object? Remember, by definition, resultant force is equal to the rate of change of momentum. The rate of change of momentum. So what is the change in momentum? So the change in momentum is going to be F times t. So the answer is going to be C. The acceleration of free fall on the surface of planet P is 1/10 of that on the surface of planet Q. So let's say the acceleration on planet P, okay, let's say it is G on Q, then on P it is going to be 1/10 of G. So we are saying G on P is 1/10 of G on Q. So which means G on P is 1/10 of G. Okay. On the surface of P, an object of mass 1.0 kilograms and a weight of 1 Newton, an object has a mass of 1 kilogram and a weight of 1 Newton. Of course, the mass remains the same. So we eliminate C and D because the mass does not depend on the acceleration due to gravity. What are the mass and the weights of the same object on the surface of planet Q? So I'll first find G on planet P. So G on planet P is 1/10 G on planet that. So the weight on P is equal to the mass times G on planet P. The weight on P is 1.0 newtons equals to the mass, which is 1.0 kilograms, then times G, which is G on P. So it means G on planet P is equal to 1 Newton per kilogram. That is G on planet P, which means G on planet Q should be equal to 10 times G on planet P, which is going to be 10 newtons per kilogram. So it means the weight on planet Q is going to be M times G on planet Q, which is 1 kilogram times 10, which is going to be 10 newtons. So the answer is going to be automatically B. A parachutist falls from rest from a balloon. The variation with the time of the vertical velocity of the parachute is shown. In which region is the force due to air resistance much greater than the weight of the parachutist? So if the force to air resistance is greater, then the parachutist decelerates very rapidly. So here, the speed is still increasing. So that means the force due to air resistance is less than the weight. Here, they are balanced. The force due to air resistance is the same as the weight. Here, the weight is greater than the force due to air resistance. Here, because it is decelerating rapidly, it is because the force due to air resistance is greater than the weight. So it slows down very rapidly. So the answer is going to be C. It is going to be C because we have a rapid deceleration. It's a rapid deceleration. So the answer is going to be C. Two solid spheres form an isolated system. Sphere X moves with speed 6 centimeters per second in a straight line directed towards a stationary sphere Y. The spheres have a perfectly elastic collision, which means the relative speed of approach should be the same as the relative speed of separation. After the collision, sphere X moves with the speed 2 centimeters in the same direction. So after it moves with the speed of 2 centimeters per second in the same direction as before. Then sphere Y moves with the speed which we don't now call that one V. So relative speed of approach should be equal to the relative speed of separation for perfectly elastic collision. So before collision, approach is 6 minus 0. After collision, separation is going to be 2. We are taking speeds to the left, speeds to in the same direction as before. So we are taking speeds to the left, the right hand side positive, speeds to the left hand side negative. So I'll say after collision, most likely the sphere y is going to have a higher speed than the sphere uh, x. So I may say v minus 2, because sphere y is in the front, so it has a higher speed than sphere x. So I will say v minus 2. So it means v is going to be equal to 6 plus 2, which is going to be 8. I can't say 2 minus v, because when I say 2 minus v, yet sphere y is in front of sphere x, it would mean sphere x is moving faster than sphere y, yet sphere y is in front. So it is going to be v minus 2. So this gives me 8. What is not a necessary requirement of the force in a couple? Remember, a couple, the forces should be equal but opposite, so act in opposite directions. They have the same magnitude, equal but opposite. They produce a resultant force. No, because they are equal and opposite, there is no resultant force. They act along different lines. They can't act along the same line, so they may end up cancelling out each other. Oh, sorry, they can't act along the same line because they may not easily cause a turning effect. So the answer is going to be D. D is not D is not a requirement for a couple. They don't produce a resultant force because they have the same magnitude and they're in opposite directions. They only produce a resultant moment. A box of length 12 centimeters and weight 0.43 newtons is placed on a horizontal table with the greater part of its length overhanging the edge of the table. The edge of the table acts as a pivot. The center of gravity of the box is at the geometric center. Okay, so the center of the gravity of the box is at the geometric center. Let me locate the center. Let's say it is here at a distance of, this is going to be 6 centimeters. This is also going to be 6 centimeters at the geometric center. So the distance from the edge is going to be 6 minus 2.4. 6 minus 2.4. So this distance is going to be 3.6 centimeters. So the weight of the box is here. Assume that the forces acting on the box are in the plane of the diagram. What is the minimum mass of the sphere that is needed to maintain the system in equilibrium? So let's say the mass of the weight of the sphere is acting here, and it is going to be the mass of the sphere times g. And this is going to cause a clockwise moment when this causes anti-clockwise moments. So the weight of the box, what is the weight of the box? So we shall say 0.43. This is 0.43 newtons times the perpendicular distance. I will just say 3.6 centimeters should be equal to mass times g, which is 9.81 for the sphere. Its perpendicular distance is the radius of the sphere, which is half of 2.4. That is going to be 1.2 centimeters. So I want to find m. M will be 0.43 times 3.6 divided by 9.81 times 1.2. Of course, the centimeters have cancelled out. So 0.43 times 3.6 divided by 9.81 times 1.2. So this is giving me 0.13. Is it? 0.13 kilograms. So that means my answer is B. An object is suspended by two ropes. One rope has a tension 4 10 newtons at an angle of 60 degrees to the horizontal. So if I resolve this vertically upwards and I resolve this horizontally, so in the vertical I would have 410 using 60 to be sine of 60. When I resolve 210 newtons to the vertical, it will point upwards. It will be 210 sine of 10. These ones are pointing upwards. The weight of the object points downwards, so this is going to be the weight downwards. Okay? The rope has tension that at that angle, the object is in equilibrium. What is the mass of the object? So I'll just consider the vertical. In the vertical, the weight, remember the weight is mg. So I'll simply say mg, which is downwards, should be equal to 410 sine of 60 plus 210 sine of 10. So the mass is going to be 410 sine of 60 plus 210 sine of 10 divided by g, which is 9.81. Okay, so I'll check my calculator. 410 sine of 60 plus 210 sine of 10 divided by 9.81. So I'm getting 39.9, which is approximately 40 kilograms. So the answer is going to be A. A solid cube is floating in a liquid mercury. The cube is made of iron of density 900 kilograms per meters cube. The cube floats with 42% of its volume above the surface of the mercury. That means the volume submerged is 58. So this is the volume which displaces the liquid. Remember, an object displaces its own volume. An object displaces its own volume. So an object displaces its own volume. So the volume displaced is going to be 58% of V. So it is 0.58 V. That is the volume displaced. So the mass of the object is going to be the density of the object times the volume of the object. That is the mass of the object. So let's say V, capital V, is the mass of the object. I mean the volume of the object. So this is going to be the density of the object is 7900, then times the volume of the object, which is V. But remember, the volume displaced is 0.58 V to gain equilibrium. So these two are supposed to be okay. So from density equals to mass over volume. So I'm now going to use the density of the liquid because I have the volume of the liquid displaced, and it means the density of the mercury. This is the density of the object. Density of the cube, volume of the cube is V. The density of the mercury is going to be equal to the mass of the object, which is going to be 7900 V divided by the volume it displaces, which is 0.58 V, because I said an object displaces its own volume. So it is going to be the volume of the liquid displaced is going to be equal to 0.58 V. And this is going to give me a let me just press my calculator, 7900 divided by 0.58, which is 1000, that is 14,000 kilograms per meters cubed. So this means the answer here is going to be C. So the volume of the mercury displaced is going to be the mass of the object over the volume of the mercury that it displaces, which is equal to, of course, for the mass of the object is the density of the object times its own volume. That's the mass of the object. But the density of the liquid is going to be the mass of the object in the liquid, or the mass of the object which is in the liquid, submerged in the liquid, over the volume that it displaces. So that gives us 14,000. The diagram shows two vessels P and Q, both with sides inclined at 45 degrees to the horizontal. Vessel P tapers outward and vessel Q tapers inwards as shown. Both vessels contain a liquid. The depth of the liquid in the vessel is the same. The liquid in vessel P is twice as dense as the liquid in vessel Q. What is the ratio? Pressure due to liquid on the base of P over pressure due to liquid on the base of Q. So we are looking at pressure at the bottom here. So H is the same for both. And remember, pressure is equal to H density times G. So I'm going to find the ratio directly. So pressure due to the liquid in P, the depth is the same. They said the liquid in P has twice density as the liquid in Q. So if Q is rho, for P is twice rho. So this will be twice of rho, then times G. Then I divide for Q, it will be H, the density is rho, then times G, which is going to be 2 over 1. So the answer is going to be A. A motor is used to lift a load vertically upwards. The load has a weight W. The motor produces useful power output P. The load is lifted at a constant velocity V. So because the velocity is constant, so it means V is equal to distance over time, or distance is V times time because the speed is constant. Which expression gives the time taken for the motor to lift the load vertically upwards through a distance D? Okay. So first of all, we know that the output power P is equal to the work done divided by time taken. That is the output power. So which means the time we are talking about here is going to be the work done divided by the power. So the time is going to be the work done divided by the power. So this is work done. Let me just write this as work, not W, because W is given as weight. But the work done is equal to the weight, which is the force, times the distance, which is capital D, then divide by the power, which is going to be P. So this means the answer is going to be C. This is work done divided by time. That is power. So when I make T the subject, T is equal to work over the power. And work is the force times the distance over the time. But the force is the weight, which is W, then distance is D over the power. So the answer is C. A lamp is switched on for 2 hours. The power input into the lamp is 1 watt. The energy given out by the lamp is 7 times 10 to the power of 3 joules. How much energy is converted to other forms by the lamp? So let's first find the initial energy. Energy input is, of course, energy input is going to be the power times time. The energy given out is 7 times 10 to the power of 3. What is the energy input? Which is power times time. So the power is 1.0. The time is 2 times 3,600. I think I just multiply this by 2 and I get 7,200 joules. That is the energy input. But the energy output is 7 times 10 to the power of 3, which is 7,000 joules. How much energy is converted to other forms? So it is just the difference in that energy. So energy difference is going to be 7,000 minus 7,000, which is going to be, So it is 7,200 minus 7,000, which is simply 200 joules. So the answer is going to be B. An object of mass m is dropped onto the surface of two planets X and Y which have no atmosphere. If they have no atmosphere, then it means air resistance is negligible. So there is no air resistance. The height from which the object is dropped and the change in gravitational potential energy of the object for each planet are given in the table. Acceleration of free fall near the surface of planet X is gx. What is the acceleration of free fall near the surface of planet gy? Let me call this one gy. So the change in potential energy is equal to mg times change in height h. Okay. So for x, the change in potential energy is going to be equal to mg x. The change in height is 3, so this is going to be times 3. Because they said the height from which the object is dropped and the change in gravitational potential energy of the object for each planet are given in the table. Then this is for x. Then for y, the change in potential energy is 4 times delta E, which is going to be m times g at y, then times height is 4. This is for planet y. So we have these two equations here. I'll get the first equation and put it in the second equation. So I'll say 4 into mg x times 3 should be equal to mg y times 4. The 4 cancels out. The m has cancelled out. So I'm seeing that g y is equal to 3 times gx. Gy is 3 times of gx, so the answer is going to be C. A non-tensile force acts on a metal wire. The wire does not exceed its elastic limit, its limit of proportionality, so it means a straight line. Which two measurements enable the strain of the wire to be calculated? Remember, strain is equal to extension over the original length. So the unstretched length, that is the original length, and the extension E. So the answer is automatically B. Strain is extension of original length. A wire is extended by different forces. The wire obeys Hooke's law, which a graph is plotted to show the variation of a quantity y with a quantity x. It can't be force against extension because force, or it can't be extension against force, because from Hooke's law, F is equal to k times x. This will be a straight line. So it can't be F against X or X against F. So I have to ignore B and C. Because F against X or X against F, it is the same line. It would be a straight line. So it means I ignore B and C. Then let's check. It has to be elastic potential energy and extension. For elastic potential energy, it is a half kx squared, which means E is directly proportional to x squared. So it means E increases more rapidly as x increases. So it means the line curves towards the side of E. So E must be on the x-axis. So this should be E because of the square on x, and this should be the extension x. So the answer is going to be x being the elastic potential energy and y being the extension x, because E is directly proportional to x squared, which means when the extension is 0, E is 0. When the extension is, let's say, 2, E becomes 4. So because the curve is becoming horizontal, it means E is on the x-axis and extension is on the y-axis. So the answer is A. A wave pulse moves along a stretched rope in the direction shown, which diagram shows the variation with time t of the displacement s of the particle p in the rope. So the wave is moving to the left. So that means this first part here, okay, this first part here should pass through the p. So it means the first, after t equals to 0, we should have a horizontal line. After t equals 0, we should have a horizontal line because this will be the first part to pass through p. So we should first have a horizontal line. So we have to check for all of them, they are having initially horizontal line. Then here, this part here will displace the particle upwards. P will be displaced upwards because this is an upward part. This section here is upwards, so P will be displaced upwards. So the first thing we should see would be P being displaced upwards. So let's check. So A is out because A is showing that P is first displaced downwards. C is also out because showing P is first displaced downwards. This part here is disqualifying the graph. So we remain with B and D. Okay. Then this part here, it has already been displaced upwards. Then this part here will be horizontal. It will remain, this part here will be now a horizontal part. So the horizontal part will now pass through P. So we need a horizontal section again. So the horizontal section again, this one shows again after displacement upwards, it just goes downwards. So this one is going to be wrong. So we need the horizontal section to come in. Then this part here passes through P, so it now goes downwards. So this is the correct section. Then this part again displaces P slightly upwards, so it should be going upwards to its original position. Let's check. Yes, it goes upwards to its original position. Then again, the horizontal part comes in. So the answer is automatically D. In other words, it's like, can I call it a reflection? Yes, it is just a reflection. Imagine you put a mirror here. Imagine you have a mirror here. What you see in the mirror here is going to be this one here, I think. So this is what happens to P. Which statement about progressive transverse and longitudinal waves is correct? Remember, for progressive particles, they transfer energy. Of course, they are both. For transverse, particles vibrate perpendicular. For longitudinal, particles vibrate parallel. So let's see, particles in transverse have a fixed equilibrium position, but those in longitudinal we do not. All particles have a fixed equilibrium position. Transverse waves can be polarized, but longitudinal waves cannot. I think this is very true. We can't polarize longitudinal waves because their vibrations are always parallel to the direction of propagation of energy. Transverse waves transfer energy, but longitudinal do not. This is not true because we can hear sound in a pipe, which is longitudinal. So both transverse and longitudinal transfer energy. It is stationary waves which do not transfer energy. Two-source interference can be demonstrated with transverse waves, but not longitudinal. Interference can be demonstrated by all waves. A miniature loudspeaker initially at rest falls vertically from a window in a high building. When the loudspeaker has fallen a distance of 10 meters, it emits a very short pulse of sound of constant frequency 250 Hz in all directions. The pulse of sound traveling at a speed of 330 is heard by a person leaning out of the window. Air resistance is negligible. What is the frequency of the pulse of sound heard by the person? So since it is moving out from the person leaning out of the window, so it means the frequency is going to be lower. So the observed frequency is going to be V over V plus. We make the denominator to be plus the speed of the source. Then this is going to be multiplied by the frequency of the source. So I'll first find the speed from V squared equals to U squared plus 2AS. It starts from rest, initial velocity is 0. So it means V is going to be the square root of 2 times A, which is 9.81, times s, which is 10. So v is going to be the root of 2 times 9.81 times 10, so which is approximately 14. So I'll just substitute. This is going to be 330 divided by 330 plus 14, then times 256. 330 divided by 330 plus 14 times 256. So this is giving me 245 point that, which is approximately 246. So the answer is going to be A. Two electromagnetic waves have wavelength 5 times 10 to the power of minus 7. I think this is visible. 5 times 10 to the power of minus 2, which I think this is micro, because this is 0.05. I think 0.05 meters. That is microwaves. Which row identifies the regions of the electromagnetic spectrum at which the waves belong? Rumenera's mother is visiting Uncle Xavier's garden. Visible light is 10 to the power of minus 7. Infrared is about 10 to the power of minus 5. This is very close, 10 to the power of minus 2 or 10 to the power of minus 3. This one starts from 10 to the power of minus 1 up to 10 to the power of 4. That is the infrared. The radio waves. So this is most likely infrared. Most likely microwave. So we have visible light and microwave. So the answer is going to be B. The other side, we have 10 to the power of minus 9, 10 to the power of minus 11, 10 to the power of minus 12, or minus 13. The wavelength of sound in air may be determined by using stationary waves. In one experiment, a loudspeaker produces a sound wave of constant frequency which is reflected directly back along the original path by a metal plate approximately 1 meter away. A microphone connected to the cathode ray oscilloscope is moved between the loudspeaker and plate to identify regions of high sound intensity and low sound intensity. The wavelength of the sound is determined using the least possible number of measurements. Of course, the least possible number of measurements will be the distance between two successive high points, which is half wavelength, or the distance between two successive low points, which is still half wavelength. So it means the wavelength is twice the distance between two successive quiet points or two successive highest points. Which row shows the quantities that are needed? We say the least possible number of measurements. So just measure the distance between two successive high spots or two successive quiet spots. So the answer here is going to be D. We don't need even the frequency. We just need the mean separation of quiet spots, which is, we don't even need the speed in air. So that is not needed. So the answer is going to be D. Half of wavelength is distance between the highest points, the loudest points, or distance between points of low sound or the quiet points. So I'll use Q for quiet and then L for loud. So the answer is D. Two progressive waves meet at a fixed point P. The variation with the time of the displacement of each wave at point P is shown. The two waves superpose at point P. What is the resultant displacement at 0.38 seconds? So I have to look for 0.38. So this is 2468. 0.38 is here. So the displacement here is 0. I think this is 0.4. And the displacement here is negative 1.4. So total displacement is going to be 0.4 plus negative 1.4, which is negative 1.0. So the answer is going to be B. that is total displacement, or resultant displacement is the algebraic sum. In which situation does diffraction occur? Of course, diffraction occurs when a wave passes through a narrow gap. Bouncing, that's not diffraction. Leaving one medium to another, that is refraction. Passes through a narrow gap, that is diffraction. Waves from two identical sources are superposed, that's not diffraction. The waves should be passing through a narrow gap, or a gap in a barrier. Light of a single frequency is incident on a pair of narrow slits that are a distance of 0.1 millimeter apart. So this is going to be light of a single frequency. It is a pair of slits, so this is going to be A, slit separation. A series of bright and dark fringes observed on the screen, a distance of 2 meters, so this is capital D. The distance between adjacent bright fringes, so this is X. What is the path difference of the light waves from the two slits that meet at the second order? So here this is N equals to second order darker fringe. Second order dark fringe. Of course, for the second order darker fringe, we expect that that is going to be a destructive interference. But remember, for destructive interference, the path difference should be equal to a half wavelength for the first, then the other one will be 3/2 wavelength, and so on and so forth. So I need to first find the wavelength. So wavelength is equal to AX divided by capital D. A is, what is A? A is slit separation is 0.1 times 10 to the power of minus 3. X is 8 times 10 to the power of minus 3. D is 2.0. So I'll just press my calculator. 0.1 exponent minus 3 times 8 exponent minus 3 divided by 2. So this is 4.0 times 10 to the power of minus 7 meters. First of all, for a darker fringe to be formed, the path difference should be an odd number times lambda over 2. So I'm just going to check the path differences to see which one gives me an odd number times lambda over 2. This one here, this one is the same as, I'm just going to divide this by the wavelength. So this one gives me, I think this is half, so this is 0.5 of lambda. That one is not going to be formed, or that is actually going to be half wavelength, or lambda over 2. That is the first. The second, this one gives me lambda, so this is constructive. This one gives me 6 divided by 4, which is 3.2. I mean 3 over 2 wavelength, or 1.5 wavelength. I think this is the second order. So the answer is going to be this one. This one gives you twice lambda, because I divide 8 by 4, which is 2 wavelength. This is constructive. This is not a dark fringe. This is bright. This is bright. This is first order. 0.5 lambda is first order. Red light of single wavelength passes through a diffraction grating. Bright dots are formed on the screen as shown. So bright dots are formed on the screen as shown. The red light is replaced with white light. Of course, white light will form a range of a range of 7 colors. Of course, at the center it will form a central bright spot, but then it will form a range of 7 colors. That means we don't expect dots as those that we saw for red. So this one, A and B, is wrong. We don't expect dots. We expect a range of colors if we replace red with white light. But remember, white light has wavelengths ranging from red to violet. And the wavelength of violet is less than the wavelength of red. That means the pattern is going to be start very close to the center, because violet is going to be closer to the center. It is going to undergo less diffraction because it has a smaller wavelength. So it means the diffraction pattern should be, or is going to be closer to the center. So if this is the center, if this is the center, and this was the original position when we had red, you see, for red, this is where we had red here, and red is at the extreme end of the visible light. So red is this side, violet is the other side. So this is going to be the correct option. This one is wrong because it's going to show that red remains here, and yet violet, yet this is white light, it can't form violet the other side. Violet should be closer to the center. So it means this is a pattern of 7 colors ranging from red to violet, but violet is going to be closer. So the position of red is remaining, but the position of violet is going to be closer to the central bright spot, which is a white spot with dark fringes on both sides. So the answer is going to be D. Nichrome. A nichrome wire has a resistance of 15 ohms, diameter 3 millimeters. The number density, so this is going to be N, of free electrons in nichrome is 9.0 times 10 to the power of 28 per meter cubed. A potential difference 6 volts is applied between the ends of the wire. What is the average drift speed of the free electrons in the wire? So we know that I is equal to NVQ times A. And remember, A is the area, which area is equal to pi d squared divided by 4. So it means if I substitute and make V the subject, V is going to be equal to I times 4. That's 4I. Why don't I just use the radius? Okay, 4I divided by pi d squared times n times q. Okay, so pi d squared times n times q. So I'm just going to substitute here. V is going to be 4 times the current, which is, where is the current? So the current is going to be, I is going to be V 6 over 15. 6 divided by 15, that is 0.4. So 4 times 0.4 divided by pi times d, which is 3 times 10 to the power of minus 3, but this is squared, times n, which is 9 times 10 to the power of 28, times q. These are electrons, so q is 1.6 times 10 to the power of minus 19, charge of an electron. So I will start with the denominator. Where should I start from? Okay, pi times 3 exponent minus 3, but this is squared, times 9 exponent 28 times 1.6 exponent minus 19. Then I will get the numerator, which is 4 times 0.4, and I divide this by the answer. So I am getting 3.9 times 10 to the power of minus 6. So the answer is going to be B. The diagrams show two different circuits. The cells in each circuit have the same EMF and negligible internal resistance. The three resistors each have resistance R. In the circuit on the left, the power dissipated is P, so power here is P. But what is that P? Of course, this P is going to be the EMF. The EMF, they said, is the same. So it is going to be the EMF squared divided by R. I'm using power equals to V squared over R, where V here is going to be the EMF. Then the power this side, I'll call it power 2, which will be the EMF squared divided by total resistance. Total resistance is twice R. When I simplify this, it is a half times E squared over R, which is power 2 is going to be a half times the first power on the left, which is P. So the answer here is going to be P over 2. That's total power in the circuit on the right. The PD across a filament lamp is increased. V is increased. I'll even sketch the graph for a filament lamp. Remember, for a filament lamp, the graph looks like this. It slightly curves. So this is, let's say this is the I against V. So when V is increased, I also increases, but the resistance increases because the temperature of the filament lamp increases. So let's see, the resistance of the lamp decreases. It doesn't decrease. It instead increases. So this is wrong. The resistance of the lamp decreases. We said this is wrong because the resistance increases. The resistance of the lamp increases. Yes, it increases. But why does it increase? Because for the filament lamp to glow, for the filament lamp to give light, it should be red hot or green hot, yellow hot, and so on and so forth. So it means the temperature should increase. And if temperature increases, the resistance also increases. So the answer here is going to be automatically D. The resistance of the film of the lamp increases because the temperature increases. As temperature increases, the resistance of the lamp increases. It's not the same with the LDR and the thermistor. For them, they are negative temperature coefficient. This one is positive temperature coefficient. A metal wire has resistance R. The wire is stretched so that the diameter decreases to 94.0%. That is the decrease in diameter. It decreases to 94.0%, which is the same as 0.094 of the original diameter. The volume of the wire is unchanged, so volume is going to be the same. What is the resistance of the stretched wire? Okay, so to begin with, I know that our resistance is equal to rho L over area. Remember, area is pi d squared over 4, so this becomes 4 rho L over pi d squared. Okay, so that is the expression for resistance. So let's say the first wire has resistance R, and R is 4 rho L over pi d squared. And for the second wire, I'll call its resistance R2, and R2 is going to be 4 because it is the same wire, so the resistivity has remained L, but the length has changed, and I have to find that length. So let me first use the volume to find the length. Remember, the volume has been unchanged. That means V1 is the same as V2, and let it be just be equal to V. But what is V1? Volume V1 is going to be pi, or it is area times the length. So it is going to be pi d squared over 4, then times the initial length, let it be L. Then volume V2 is going to be pi. The diameter decreases to 94 point that. So this is going to be 0.94 d squared divided by 4. The length is not known. I'll call the length L2. Remember, V1 and V2 should be the same. V1 and V2 should be equal. And if that is very true, so I'll simply equate these two equations. So when I equate the two equations, I have that pi into 0.94 d squared divided by 4. L2 should be the same as pi d squared L divided by 4. So pi cancels, 4 cancels, and I'm remaining with L2 equals to d squared cancels. I remain with L over 0.94 squared. So the length of the second wire is 0.94 squared. 1 over 0.9, L over 0.94 squared, or 1 over 0.94 squared times L. So I'm now finding the new resistance. I'll call it R2. R2 is going to be 4 rho divided by pi. The new diameter is, remember, 0.94 times d, but this is squared. Then the new length, L, is this is L over 0.94, but this is squared. That is the new length. So I'm now trying to simplify this. So this is going to be 4 rho L over pi. I'm pulling out d, so it will be pi d squared times 1 over, so it have 0.94 squared times 0.94 squared, so it is 0.94 raised to power 4. So this one alone is the initial R that we had before, which is this one here. So it means R2 is equal to R times that, which is R over 0.94 raised to power 4. I'll check this. 1 divided by 0.94 raised to power 4. So it's 1.28. So this is 1.28 times R. So the answer is going to be D. The diagram shows a cell of EMF 3 volts and internal resistance 4.7 ohms connected across a lamp. The lamp has a resistance 9.3 ohms. What is the power dissipated by the internal resistance of the cell? Okay, so I'll first of all let me try to find a current. I'll put in a loop by Kirchhoff's second law. I can put in a loop. If I use Kirchhoff's second law, so the EMF is 3.0 volts equals to the current. Let's say the current is I, so this is going to be I into total resistance, which is going to be 9.3 plus 4.7. So it means I is going to be 3 divided by, I think this is 14. That is the current. So I want the power in the internal resistance, which is 4.7. So remember the current is the same. So power in the internal resistance is going to be I squared times R, which is going to be 3 over 14, but this is squared, times the internal resistance, which is 4.7. So 3 divided by 14 squared times 4.7. So this is giving me 0.22. So the answer is going to be A. Oh, this was in amperes. A circuit of a battery, a high resistance voltmeter, and 4 fixed resistors are as shown. The battery has EMF 15 volts and negligible internal resistance. What is the reading of the voltmeter? So the voltmeter is going to give a potential difference between 24 ohms and 6 ohms, then subtracted. So the PD across 24, of course the 15 is going to be divided in the ratio of the resistances. So PD across 24 ohms is going to be 24 divided by, I'm using the potential divider formula V out equals to R, the resistor we are considering, over total resistance times the voltage supply. So this will be 24 over 24 plus 6, which is 30 times 15. And I think this is 12 volts. So this is 12 volts, which means this is automatically going to be 3 volts. Then the PD across 6 ohms. PD across 6 ohms is going to be 6. I'm now considering this part here. Remember, the EMF of 15 volts is the total PD across the two resistors in series. So it will be 6 over total, which is 6 plus 9, which is 15. I'm considering this 6 ohms here on the left-hand side, 6 ohms on the left. So it is 6 over 15 times 15, which gives me 6 volts, which means the PD across 9 ohms is going to be 15 minus 6, which is 9 volts. Okay, so if I want the reading of the voltmeter, the reading is going to be the difference in the potential. Reading is going to be 12 minus 6, which is 6 volts. Or this is the reading, or it can be 9 minus 3, which is still 6 volts. I can find the potential difference along this junction here by considering 9 volts minus 3 volts, or 12 volts minus this one here, which is 6, which was 6 volts. So the answer is automatically 6. You just find difference in potential because they join the same point, they only differ at these other 2 points. So just find a difference in potential between the other 2 ends. A potential divider circuit is designed to detect the difference in temperature. Between two different places. The cell has EMF of 20 millivolts and negligible internal resistance. Initially, thermistor X and Y are the same temperature and have the same resistance. So if they initially have the same resistance, it means initially this is 10 millivolts and this one is also 10 millivolts initially. The voltmeter reads 10 millivolts. X is then placed in a cold environment. Remember, X is a thermistor. That means the temperature here decreases. If the temperature here decreases, it means the resistance of X must increase. Remember, they're in series. If the resistance of X increases, in series, the current through them must be the same current. It means the PD across X is most likely going to increase. But of course, to conserve energy, it means the PD across Y must decrease. So it means PD across Y must by all means decrease. But let's see what has happened here. Y is placed in a warm environment and its resistance halves. X is placed in a cold environment and its resistance doubles. So here I will just use a calculation. I'll use a potential divider formula. PD across Y is going to be, V out is equal to R out divided by total resistance times the voltage supply. So PD across Y is equal to, the resistance of Y is half. So I'll say R out is a half of R. Total resistance is going to be, the other one is doubled. So this is twice R plus a half of R. Then I multiply this by the voltage supply, which is 20 millivolts. So the PD, the question is, what is the new reading on the voltmeter, which is the PD across Y? So this is going to be, R has cancelled out, I think, or it is 0.5 divided by 2 plus a half. I think that is 2.5. Is it? Yes, 2.5. Then times 20. R has cancelled out. Times 20. So you can check 0.5 divided by 2.5 times 20, which gives us 4. So this is 4 millivolts. So the answer is automatically A. You could find the PD across X using the same method. Then you subtract it from 20. Then you get PD across Y. Particle physics. In the alpha particle scattering experiment, a beam of alpha particles is aimed at the gold foil. Most of the alpha particles go straight through or are deflected by a small angle. A very small proportion are deflected by more than 90 degrees, effectively rebounding towards the source of the alpha particles. Which conclusion about the structure of the atoms cannot be drawn from this experiment alone? This experiment alone only tells us that most of the mass is concentrated at the center of the nucleus, which is positively charged, and most of the atom is empty space. Only that. So most of the atom is empty space. Most of the mass is concentrated at the center of the nucleus. The nucleus is positively charged. We cannot tell that the nucleus contains both protons and neutrons, because after all, even the neutrons have no charge. So we can't tell that the nucleus has both protons and neutrons because the neutrons have no charge. So this experiment alone is not enough to tell us that there are also neutrons in the nucleus. Even though we know that protons are positive, they contribute to the charge of the nucleus. How about the neutrons? So another experiment is needed. And lastly, which two particles have opposite charges? Let's see. Alpha particles, helium. An alpha particle is a helium nucleus, so these ones have the same charge. Antiproton, that is E power, an antiproton has a negative charge. Beta plus has a positive charge. It is a positron. So the answer is going to be B. Antiproton has a negative, an opposite charge to a proton. Beta plus has a positive charge. Beta minus has a negative charge. The electron has a negative charge. The positron has a positive charge. The proton has a positive charge. So the answer is B. And lastly, which particle is a lepton? Of course, a lepton, a particle which is not affected by the strong nuclear force. And this is a meson is made up of quarks. It is a baryon. A positron, that is beta plus, that is a lepton. A proton is made up of quarks. A quark is not a lepton. A quark is a particle which makes up the baryons. So the answer is going to be B. A positron is beta plus. This is beta plus, which is a lepton. I think that marks the end of 1, 2. See you in 1, 3. Until next time, bye bye.